Welcome back, ladies and gentlemen. In this video, we are discussing a brand new chapter, and we are diving into what we know as similar polygons. The goal of this section is to be able to utilize similar polygons in some mathematical applications. More specifically, in this video, we're going to define what similar polygons are. We're going to talk about what we know as similarity transformations. We're going to be able to identify corresponding parts of different polygons, and we're also going to kind of revisit the topic of scale factors. So what I want you to kind of think of as we open up this discussion here about similarity is when two figures are similar, a good way to think about it is as they are proportionate. If you remember correctly back when we talked about transformations, we talked about things like rigid motion. And rigid motion or isometry were basically when you could map a figure onto another one, but it didn't change the size or the shape, right? So we ended up having the exact same angle measures and the exact same sizes when it was isometry. But then we incorporated dilations, and dilations preserved the angle measures, but we either enlarged it or reduced it. And that is a similarity transformation. And so when two polygons are similar to one another, they preserve the angle measures, right? So they preserve the angle measures, but they are enlarged or reduced by a certain scale factor. And we're still calling the scale factor K. So when we kind of think about proportions, we also start thinking about the concept of ratios, right? So proportional and ratios, they kind of all go together a little bit. And so let's think about this here for a sec. What we're saying is, if I take, for instance, EF, right? EF and BC, they are corresponding side lengths in these two similar figures. How do I know that? Because one is in between the two arcs, 3 arcs, 2 arcs, 3 arcs. I know those two match on up. So what do we end up seeing? Well, we see that they are corresponding. So let's see if I made a ratio of EF to BC. Well, the value of EF is KX, and the value of BC is A. What do you notice? At top and the bottom, the numerator and denominator both have A, they would equal K. Let's just say, for instance, I do that for the other sides. I see that DE is similar or corresponding to AB, and look what happens. You get KC over C, and the C's would cancel on that, and once again you get K. You're starting to notice the pattern here, right? So that scale factor is what tells us how bigger or smaller it is going to be getting. But more specifically, all of these ratios, every single one of those ratios are going to equal the scale factor as well. So it's very, very important to know. Each of these ratios are going to equal our scale factor. So in the next slide, we're going to look at a couple of examples where we identify the scale factor, list the congruent angles, and then we're going to talk about how to write some statements of proportionality. So it says find the scale factor of triangle RST 2XYZ. And let's talk here for a sec. I'm going to circle this symbol up here. That is the symbol, that little squiggle, that is the symbol for similarity, right? So let's just recap. Remember, this is our congruency, and just the squiggle is our similarity. So find the scale factor. Well, to find the scale factor, you want to always think about nu over old. Nu, should give myself a little bit more room. Nu over old. So we're going from RST to XYZ. That means that the nu is XYZ. And so we need to find out which ones match up. Well, you can choose any which ones of these sides, and we see that YZ matches up with ST. And so in that case, you get 18 over 30. 18 over 30. We want to try to simplify this as much as possible. So 6 goes into 18 3 times, and 6 goes into 30 5 times. So that scale factor would be 3/5. And I'm going to write that, that's equal to K. This K is our scale factor. You want to list all of the congruent angles. Remember, guys, all you need to really do is just match up which letters correspond to which letters in how it is written for us, because they'll have it written in a similarity format. So we have angle R angle x, we've got angle x is angle t, and we have angle y, back up a little bit, angle y, and finally we have angle t being congruent to angle z. All right, and we're just matching on up which ones are corresponding. And the last thing it says is write a statement of proportionality. Guys, that simply is just writing all of the corresponding ratios that would be equal to one another. So for instance, we've already identified that YZ is to ST. And we also can say that, hey, we know that YX is to SR, just as XZ is to RT. So this right here would be our statement of proportionality because all of those ratios are equal to one another.